Hi, my name is Richard and welcome to my channel. In today's video, we are going to continue to solve Valley View University end of semester examination on ordinary differential equation. That's the semester of 2022-2023 academic year. So remember, in this examination, there was two sections, section A and section B. And in section A, where there are 5 questions, and we are supposed to answer all for 40 marks. So I have a video where we solve all the questions from question 1 to question 5. In this video, we will go to the section B and solve question 6 and question 7. And I will indulge you to check up my videos, the part 2 of this, where we solve the remaining questions in section B. So come along as we find solution to the question 6 and the question 7. So the question 6 is having two parts, A and B. The A says that consider the following non-homogeneous linear differential equation y prime prime minus 2y prime equal to t exponent negative t exponent negative 1 e exponent t, where t is greater than 0. The general solution of the corresponding homogeneous equation is given as y of h equal to c1 e exponent t plus c2t e exponent t. Find the complete solution of the non-homogeneous equation. So anytime we are faced with a non-homogeneous second order ordinary differential equations, two things comes into mind. We must solve the homogeneous side, then after that we find solution to the non-homogeneous side. Fortunately for us, the solution to the homogeneous side have been provided. So ours is to find solution to the non-homogeneous side. And to solve that, there are a lot of methods we can use. Method of undetermined coefficient, variation of parameters, then the D operator method. So in this, I'm going to use the method of variation of parameters to solve this. So remember, we said the solution, according to the principle of superposition, y of t will be equal to y of h, which have been provided. That's the complementary solution to the homogeneous side, then plus y of p, which is the solution to the non-homogeneous side. So y of h have already been provided, so we find y of p. From the method of undetermined variation of parameters, y of p is given as negative y1, that's negative y1, the integral of y2 g of t over the Wronskian of y1 and y2, then plus y2, remember dt, then plus y2, the integral of y1 g of t over the Wronskian of y1 comma y2 dt. Nice one. So what's our y1? Our y1 is equal to the e of t. That's the coefficient of the first constant. Then the y2 becomes the coefficient of the second constant, which is t e exponent t. Then our g of t becomes the non-homogeneous side, this one. That's t exponent negative 1 e exponent t. So now we need to find the Wronskian. So remember, the Wronskian of y1, y2 will be equal to the determinant of the y1, which is et, then the y2, which is t-et, and they are differentials. So when we differentiate this, we'll get e exponent t again. Then remember, we have to use product differentiation to differentiate this. So I'll differentiate the t and keep e exponent t. When I differentiate t is still 1, so that will be e exponent t, then plus. When I differentiate e exponent t, it will still be e exponent t, so plus t e exponent t. So we'll find the determinant of this matrix, and that becomes the Wronskian. So we can say the Wronskian of y1 comma y2 will be equal to this times this. So when this multiply this, we'll get e exponent 2t, that's this times this, then plus t e exponent 2t, using what's the name, indices. So this times this, Since they are multiplying with the same base, we just add the exponent. Then minus this times that. So that will be t e exponent 2t as well. Then the Roskian of y1, y2 becomes, remember this will give us 0, it's just e exponent 2t. So we know the Roskian, we know y1, we know y2, we know g of t. We just substitute into this and find our y of p. So having substitute that, we know our y of p, our y1 is e exponent t. So we have negative e exponent t. Then the integral of y2, which is t e exponent t. G of t, remember, is t exponent negative 1 e exponent t, and that's that. Over the Roskian of y1 and y2, and that's e exponent 2t. Then plus y2, and our y2 is t exponent t. The integral of y1, which is e exponent t. G of t, which is t exponent negative 1 e exponent t, over the Roskian again of y1 and y2, which is e exponent 2t. So we will simplify this. So our y of p then will be equal to, so I have negative e exponent t, the integral. So t exponent 1 times t exponent negative 1, that will be t exponent 1 plus negative 1, and that will be 0. T exponent 0 is 1. So we have e exponent t times e exponent t will give us e exponent 2t over e exponent 2t dt. Then plus t e exponent t, the integral of, so this will multiply that again. So we have t exponent negative 1 e exponent 2t over e exponent 2t dt. So our y of p will be equal to negative e exponent t times the integral. So e exponent 2t times divided by e exponent 2t will just be 1. So 1 dt, then plus t e exponent t integral. This also divide that. So we'll be left with 1 over t. Remember that I using this is, or t exponent negative 1 dt. So what are we having? We have our y of p is equal to negative e exponent t integral of 1 dt plus t e exponent t, the integral of 1 over t dt. This using indices. So we now differentiate, integrate, sorry. So our y of p will be equal to e exponent t. When we integrate this, we'll get t, then plus t square e exponent t plus t e exponent t. Then the integral of 1 over t will be ln t, then plus our constant of integration. So since there are C1 and C2 already, we'll let this our constant be C3. That's our constant of integration. So having found that, we can rewrite this as y of p is equal to t e exponent t ln t minus t e exponent t, then plus the constants. So we know the solution to the homogeneous side, which is given to us in the equation. Now we have found solution to the non-homogeneous side. We bring them together using the principle of superposition. So our y of t will be equal to c1 e exponent t plus c2 t e exponent t, then plus y of p, which is t e exponent t ln t minus t e exponent t, then plus our C3. Then this becomes our general solution to the differential equation. We'll go to the B aspect of this question 6. So the B aspect of question 6 says that we should find the complete solution of the second order non-homogeneous linear equation y prime prime minus 2y prime plus 5y equal to 5t squared plus 6t minus 12. So I've been saying time without numbers that anytime we are met with a second order ordinary differential equation, then we must find out whether it is homogeneous or non-homogeneous. Likely for us, the question says it's non-homogeneous, and it is true because it is not equated to 0. It is equated to another function. If that's the case, then we have two solutions. We combine using the principle of superposition. That's our general solution y of t will be equal to the solution to the non-homogeneous side. That's complementary solution to the homogeneous side, then plus the solution to the non-homogeneous side. So now we find solution to the homogeneous side. That's we set up the equation. So when we set up this to 0, then this becomes homogeneous. Then we find the solution. So we let our y to be equal to e exponent r of t. Then we find our y prime to be r. That's we differentiate this. We get r e exponent r of t. Then y prime prime will be equal to r. So our y prime prime will be equal to r square e exponent r of t. Having gotten that, we substitute this to the equation. So our y prime prime is r square e exponent r of t minus 2 r e exponent r of t plus 5 e exponent r of t equal to 0. So e exponent r of t is common to them, we factor it out. So r squared minus 2r plus 5 e exponent r of t equal to 0. So now we divide both sides by e exponent r of t. So we get r squared minus 2r plus 5 equal to 0. Now this becomes a quadratic equation. The root of this quadratic equation will determine the form of the complementary solution. So now we solve this. We solve this using quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. So our a is 1, b is negative 2, and c is 5. So now we substitute to find our r. Our r will be equal to negative b is negative 2 plus or minus the square root of negative 2 square minus 4 times 1 times 5 all over 2 times 1. So what I have, r is equal to 2 plus or minus the square root of 4 minus 20 all over 2. So our r then will be equal to 2 plus or minus the square root of 4 minus 20. That will give us negative 16 all over 2. So I have 2 plus or minus the square root of negative 16 will be 4i all over 2. So our r will be equal to 1 plus or minus 2i. So we have a complex solution. And remember, anytime our resultant quadratic equation from our differential equation is complex, the general solution y of c will be equal to e exponent lambda t times cos beta t plus sine beta t, where our lambda is the real part, the value of the real part, which is 1 here, and our beta is the coefficient of the complementary part. Therefore, we can say our complementary solution will be equal to e exponent t, that's 1 times t will still be t, times, remember there is constant here, a and b, sorry about that, so a cos 2t, beta is 2, then plus b sine 2t. So now we know the solution to the complementary side. Now we find solution to the we know the solution to the non-homogeneous side. Now we find solution to the homogeneous. So we find solution to the homogeneous side. Now we go to the non-homogeneous side, and the form of the non-homogeneous side will determine what we should let the y of p be. So this is a quadratic. So we let it be the general form of quadratic equation. So we say let y of p. Please remember, I'm using the method of undetermined coefficient. So y of p will be equal to at squared plus bt plus c. So I'll differentiate this. I'll find y prime. So our y prime, which is the differential of this, will be 2at plus b. Then we'll find the y prime prime since there is such. So we have y prime prime to be equal to 2a. That's the difference. Remember, the a, b, and c are all constants. So now we substitute 1, 2, and 3 into our differential equation. So we can say in place of y prime prime, we have 2a minus 2y prime, which is what? Which is 2at plus b, then plus 5. Our y is what? Is at square plus bt, then plus c. And this will be equal to 5t square plus 6t minus 12. So we expand, we get 2a minus 4at, then minus 2b, then 5 plus 5at square plus 5bt plus 5c, and this will equal to 5t square plus 6t minus 12. We group like terms. So I'll bring the square term first. So I'll have 5at square being the only square term. Then the t terms, which is minus 4at, then plus 5bt, that's this. Then constant terms, plus 2a minus 2b, then plus 5c. All that equal to 5t square plus 6t minus 12. Okay, so we have 5at square, then I'll rewrite this to be plus 5b plus 4 minus 4a, then all that with t, then plus my constant 2a minus 2b plus 5c equal to so plus 16 minus 12. So now we compare. You see that this is equal to that. So we can say the coefficient of the square term here will be equal to the coefficient there. That's 5. So our a will be 1. When we divide both sides by 5. Then this will also be equal to 6. So we can say 5b minus 4a is equal to 6. We got our a to be 1 already. So we say 5b minus 4 times 1 will be equal to 6. 5b minus 4 is 6. 5b will be 10. Then b is equal to 2. Now, the constant will also be equal to constant. So we can say 2a minus 2b plus 5c will be equal to negative 12. So we have 2, our a is 1, minus 2, b is 2, plus 5c is equal to negative 12. So 2 minus 4 plus 5c equal to negative 12. So 2 minus 4, that will be negative 2, plus 5c equal to negative 12. So we can say 5c is equal to negative 12 plus 2. 5c will be equal to negative 10, and c will be negative 2. So, having known that, we substitute here. So we know a to be 1, a is equal to 1, b is equal to 2, and c is equal to negative 2. We substitute here to get the y of p. So our y of p will be equal to t squared plus 2t minus 2. So we can say our general solution, or the complete solution to our differential equation, will be equal to the complementary side, which is e exponent t bracket a cos 2t plus b, or this will be sine 2t plus b sine 2t, then plus t squared, then plus 2t minus 2. Then this becomes the complete general solution to this our differential equation. I hope you get that. So the question 7 says, that's the A aspect. It said determine if the differential equation on the board is homogeneous, and that is worth 8 marks. So if you are asked to find if a differential equation is homogeneous, we use a very important theory, which is Euler's of homogeneous functions. So remember Euler's theory of homogeneous functions. So we let our y prime to be equal to, this becomes a function depending on two variables. So we say a function x comma y. So we can say f comma y is equal to 2xy e exponent x over y all over x squared plus y squared sine x over y. So what does Euler's theory of homogeneous functions say? It says that we should introduce a parameter lambda to affect the variables x and y. Then if we factor the common parameter lambda out and we still get a function, that means the function is homogeneous. But if we didn't, then the function is not homogeneous. So we introduce a parameter lambda. So we say f of lambda x comma lambda y. So this will be equal to 2. That means any place we see x now, we substitute lambda x. And any place we see y, we substitute lambda y. So we have 2 lambda x times lambda y e exponent lambda x over lambda y. I hope you get that. All over lambda x all square plus lambda y all square sine bracket lambda x over lambda y. So what are we having? We have 2xy for the top, lambda square. Then this lambda will divide that lambda. We have e exponent x over y all over lambda square x square plus lambda square y square. Then sine, lambda can divide lambda, we have x over y. Okay. So what are we having? We have 2xy lambda square e exponent x over y for the numerator, and then the denominator lambda square is common to them, so we can say x square plus y square, then lambda square out, sine x over y. So you can see that this lambda square can divide that lambda square. Then our f of lambda x of lambda y will be equal to 2xy e exponent x over y all over x square plus y square sine x over y. So let's see, did we get a function back? Is it the same as a function? Yes. So we can see that f of lambda x lambda y is equal to f of x y. Hence, the function is homogeneous. So we can say that since f of x y is equal to f of lambda x lambda y, then the function, remember, is having a degree. The degree here, remember, since there is no lambda, that means the degree is 0. So the differential equation, the differential equation y prime equal to 2xy e exponent x over y all over x square plus y square sine x over y is homogeneous. Is homogeneous with degree 0. With degree 0. So that's it. How to determine if a differential equation is homogeneous. So now we go to the B aspect of the question 7, which is worth 12 marks. So the B aspect of the question 7 says that write down the form of the particular solution to the differential equation y prime prime plus pty prime plus qty equal to g of t for the following g of t, and there is an instruction there: do not solve it. Do not solve. So it's just that we have to find the general solution to the g of t. So remember, this equation in this form becomes non-homogeneous if the g of t is not 0. And remember, these g of t's are all given is not 0. So we can use the method of undetermined coefficients to determine a g of t. However, it has been solved and they are asking for the general form of it. So remember, anytime we have a trigonometric function, that means the what's the name? The general solution or the quadratic equation is a complex one. It's a complex system. And when it happens like that, the general solution to this, so let me solve the first one. So for the cosine 10t, the each general solution, remember, will be a cos 10t then plus b sine 10t. That will be the general form of the trigonometric function sine. Since it's having an each function, we just use it to multiply, leaving the constant. Anything constant, we leave it. Then we can say that so we multiply our e exponent t across it, then that becomes the solution, the general solution to the non-homogeneous side. So our yp of t will be equal to e exponent 7t bracket a cos 10t then plus b sine 10t. So we can still expand this to get our and say our y of p of t will be equal to a e exponent 7t cos 10t plus b e exponent 7t sine 10t. So this will be for the first one. I hope you get it. Now let's go to the second one. That's g of t is equal to 9t squared minus 103t cos t. So you can say for the trigonometric function for cos t, the general form will be a cos t plus b sine t. That's when the constant here is, let's say, 1. However, the constant here are what? What's the name? The constant there is a trigonometric, is a quadratic function. So we can say for 9t squared minus 103t, each general form will be c t squared plus dt then plus e. So we'll just multiply this general form of the trigonometry of the quadratic function with the general form of the trigonometric function, and that becomes the y of p. So our yp of t will be equal to the trigonometric function, which is the quadratic function, which is ct squared plus dt plus e, then times the trig form, which is a cos t plus b sine t. So we can still expand this and write ct squared plus dt plus d times t plus e a cos t then plus ct squared plus dt plus e times b sine t. Then this becomes the general form for this. Now let's look at the third one. So the third one, which is negative e exponent minus 2t 3 minus 5t cos 90. So remember, this is a linear function multiplying the trigonometric functions. So for the linear function, the general form of the linear function 3 minus 5t will be at plus b. So these constants will multiply the general form of the trigonometric function, then multiply the e function. So the general form of the trigonometric function cos 90, remember, will be equal to cos, okay, a constant, let's say a cos 90 plus b sin 90. Whilst these constants are what is multiplying that. So we can say we should let our a to be equal to at plus b, and the b should be equal to ct plus, let's say, d. So this will multiply that. So we'll have at plus b cos 90, then plus ct plus d sine 90. So what do? We will now distribute the e function over 8. So we can say our yp of t will be equal to e exponent negative 2t at plus b cos 90, then plus e exponent negative 2t ct plus d sine 90. Then this becomes the general form for the third one as well. I hope you get that. Now we'll go to the 8th question. So end it here for this video. So we'll look at the question 8 and question 9 in the part 2 of this video. Please remember to subscribe to my YouTube channel, like, share, and comment, because your comments keep me going. Until we meet again, my name is Kepsi.